create a new document and insert a graphs application. Press Menu, Geometry, Construction, and select Perpendicular Bisector. Place a point on the x-axis. Make sure that the point is not located on a hash mark. Now place the second point on the y-axis. Press Escape to release the Perpendicular Bisector tool. Move the mouse over the end of the bisector and grab the end of the line and extend it to the edge of the screen. Repeat this for the other end of the perpendicular bisector. Press the Menu key, select Geometry, Construction, and this time select Locus. Click on the perpendicular bisector, then select the point on the x-axis. The result is a visual representation of the path that the perpendicular bisector follows as the point is moved along the x-axis. Press Escape to release the Locus tool. Grab point B and move it. Now we can see how the path of the bisector is affected by point B. The locus forms an envelope that appears to be in the shape of a parabola. Drag point B to 0, 2. Press Tab and type the equation 1/4 x squared plus 1. It looks like a good model for the envelope formed by the locus. I'll repeat the construction process on a second graph application. This time I'll include some additional construction lines. No need to follow along, just watch. The distance from P to the x-axis is the same as the distance from P to the point on the y-axis. How can this equation be derived? Well, point P has the coordinates, let's say, x, y. The distance from P to the x-axis is simply the value y. I'll call that d1. d2 can be the distance from P to the point on the y-axis. We can calculate that distance by using the formula for the distance between 2 points. We showed that d1 is equal to d2 through congruent triangles. I can square d1 and d2, that will get rid of our square root sign, and we're left with a relationship y squared equals x squared plus y minus 4 all squared. Expand the brackets, simplify, transpose, and we get left with the equation y equals 1/8 of x squared plus 2. Parabolas aren't the only shapes we can form using a locus. Watch the rest of this video to see some other graphs created using the same technique. See if you can figure out the properties of the graphs by looking at how they've been constructed. Remember, you can pause or rewind the video at any time.